Let's take a look at the conjugate acid for ammonia, NH3, and we'll do that by looking at ammonia plus water plus H2O. So to start out with, we know that ammonia, NH3, is a base. This is one that you should memorize. It's pretty common. It's considered to be a weak base, but it's a base. That means if ammonia is a base in this reaction, water, that's going to be acting as an acid. So we have this information already. If we look at the Lewis structures here, what's happening is bases, they'll accept protons, and acids, they'll donate protons, according to the Bronsted Lowery theory. So the water here, it's going to donate a proton because it's an acid, and that proton's just H+, just the proton comes over here, and it bonds with the nitrogen. So now we have this NH4, and since we got a proton, an extra H+, this is now positive. So let's move this over. In this line here, it represents a pair of electrons. So let's change that to a lone pair of electrons here. And now, since we've lost this positive charge, this becomes negative. And you should recognize this as OH-, the hydroxide ion. So let's move that over to the other side as well. So now when we look at these ions here, we see that the NH4+, the ammonium ion, has an extra hydrogen. This could donate this to some other compound, could donate it back to the hydroxide ion here to form NH3 again. Because of that, we're going to call NH4+ a conjugate acid. It is the conjugate acid of the base ammonia. And then over here, you should always recognize OH- as being a base. This is considered the conjugate base from water, which was acting as the acid. We should note that this is an equilibrium. Most of the NH3, it's very soluble in water, but most of it stays as NH3. It doesn't convert over to the ammonia and the hydroxide by reacting with the water here. So let's put these over here because we'll still have these in solution as this right here. They'll both be the aqueous ammonia and the liquid water. So to recap, ammonia is the base. It accepts a proton to become a conjugate acid, and then water, that's the acid. It lost the proton here, and now it is the conjugate base. This is Dr. B looking at the conjugate acids and bases involved in ammonia plus water. Thanks for watching.